morning. I haven't received any questions from you yesterday. I think this is due to XB was not working yesterday. So you still have a chance. Send me questions at any time you like, and I will answer them as soon as I can. All right. We're still working on factoring. I am going to do another lesson on factoring, and this is called difference of two squares. I want to remind you that if we have a quadratic in factored form like this, a minus b, a plus b, this is a quadratic in factored form, and if we want to expand this, I told you this is called conjugate because they are exact terms and opposite signs. So if we want to expand this, we don't need to FOIL. There is a shortcut. We just need to square the first minus square the second. And example for that, if I have 2x minus 5, 2x plus 5, we can expand this without FOIL by squaring the first. So square 2x, it will be 4x squared, minus, it's always minus here, square the second, which is 25. Today we are going to do the opposite operation. We're going to have this in standard form, and we're going to return it to factored form. So this is the factoring of the difference of two squares. So what we are going to do, if I have a quadratic in this form, a squared minus b squared, if I want to factor it, all I need to do, open two brackets, square root of the first, square root of the second, square root of the first, square root of the second, then we put minus and plus. That's it. So if we have something like, I will give you a lot of examples today. Let's say we have a squared minus 4, and I want to factor this. Is this difference between two squares? Yes. This is a perfect square. This is a difference minus, and this is a perfect square. So I can factor this by having square root of the first, square root of the second, square root of the first, square root of the second, and opposite signs, plus or minus, it doesn't matter. I can put plus here and minus there, it doesn't make a difference. Okay? Now another example, n squared minus 64. Same idea. N minus 8, n plus 8. Square root of the first, square root of the second, opposite signs. 81 minus x squared. Same idea. Square root of the first 9, square root of the second x, square root of the first 9, square root of the second x, opposite signs, plus and minus. Okay? Let's say c squared minus 100. Same thing, c minus 10, c plus 10. Okay? Now, let us have a tricky one. K squared plus 25. Here I have a perfect square and perfect square, but this is not difference. This is plus. So simply can factor. We must have a minus in between. It is called difference of two squares. So it must be difference between two perfect squares to factor. Let's say I have 1 minus 49y squared. This is a perfect square and this is a perfect square, and minus between them, so I can do that. Square root of the first, square root of the second, square root of 49 is 7, square root of y squared is y. The same thing, then opposite signs. 9b squared minus 100. Same thing. Square root of the first, there is a minus here, so yes, square root of the first, square root of the second, square root of the first, square root of the second, opposite signs. Okay? 7, 5x plus 7. Right? Okay. Now let's go 16a squared minus 121. Yes, this is a perfect square, this is a perfect square, there is a minus between, so I can open two brackets, square root of the first, so square root of 16a squared is 4a, 4a, square root of the second, 11, 11, opposite sign. Okay, now let us have another one, 49 x to the power of 4 minus 16, so to the power of 4, sorry. Perfect square minus in between. So 7x squared, square root of x to the power of 4 is x squared, minus 4, 7x squared plus 4. This can be factored more actually, because this, I can factor this. I can put here square root of 7x minus 2, square root of 7x plus 2, and this we cannot do anything about it because it has a positive in between, right? Okay, so this is the first part. So for example, if you have 5x squared minus 3, we can still can factor this. We can write this as square root of 5x plus 3 plus square root of 3 square root of 5x minus square root of 3, because square root of the first minus we can get the square root of that and get the square root of that, so we can factor it this way. Okay, another thing, multi-steps. So now we are going to do multi-steps. So if we have 24a squared minus 54b squared, and I want to factor this, I told you before, the first step of any factoring process should be look for common factors. What is, so we see here what can be common in there. What is the highest common divisor? I see that both of them can be divided by 6, and 6 is the highest divisor for all of them, for both. So if I factor 6 out, I will get, divide this by 6, I'll get 4a squared minus 9b squared. Now 6 stays, and I can factor this because this is difference of two squares. So I will factor like what we did before, square root of the first, square root of the second, square root of the first, square root of the second, opposite signs. Okay, so we are doing one step more, which is factor the common factors, then factor what is left inside. Okay, let me give you some other example. Yeah, we still have time. 45q cubed minus 20q. When I look at this, the first thing I would do is I look for common factors. What is common? It is very clear that the highest common divisor here is 5, and the highest common divisor, the highest common variable here is q. Then what will be left inside? We divide each term by the common factor. So 45 divided by 5 is 9. Q cubed divided by q is q squared, minus 4. 20 divided by 5 is 4. Q divided by itself is 1. Okay, now we can factor. 5q stays. Then we can factor this as difference between two squares. Square root of the first, square root of the second, square root of the first, square root of the second, opposite sign. Okay, so this is multi-steps. Factor the common factor. factor, then do the difference between squares. Another example. X to the power of 4 minus 48x squared, and we need to factor this. So again, I will look for common factors. 3 is common and x squared is common. When we divide, we subtract the power, so 3 divided by 3 is 1, x to the power of 4 divided by x squared is x squared, minus 48 divided by 3 is 16, x squared divided by itself is 1. Now 3x squared stays, and we factor this as difference between two squares. So what we do, square root of the first minus square root of the second, square root of the first plus square root of the second. Alright. One more. 8x squared y minus 32y cubed. So when I look at this, 8 is common, y is common, then what will be left inside is x squared minus 4y squared, because I divided this by 8y, so 1, y and y cancels out, x squared, negative 32 divided by 8 is negative 4, y squared divided by y is y cubed divided by y is y squared. Okay, so now this is 8y stays, and this is difference between two squares, so x minus 2y, x plus 2y. Alright, now I still can do one more, I guess. M cube n minus mn. So again, common factor is mn. What remains inside is m squared minus 1. Mn stays because I get this by dividing each term by mn. So m squared divided by n, m is m squared. M cubed divided by m is m squared. N divided by itself is 1. Then this divided by itself is 1. Now we factor this as difference between two squares. So m minus 1, m plus 1. I don't know, we can do one more. Yeah, okay. One more example. 3n squared minus 147. So 3 is common. That will leave n squared minus, I divide this by 3, 14 divided by 3 is 4, and 9. Now we can factor this, difference between two squared, so n minus 7, n plus 7. Okay, I will stop here. I want you to do page number 3 on the package I'm going to post from number 1 to number 24. You can check your answers by FOIL and see if you get back the original one. Okay? Please send me your questions until I see you in the next video. Have a great day.